Okay, hello. Happy Thursday? Thursday. Welcome to part 28 of this, me writing a WebAssembly interpreter in Ruby. Why am I doing this? I'm doing it to have fun. I'm doing it to demystify WebAssembly. And I'm doing it to just show you how I work on this kind of project. I am reminding myself here that the point of this is to have fun. Doesn't matter whether I make a functional Ruby WebAssembly interpreter at the end of this, as long as I've enjoyed myself. I want to prioritize writing correct code, even if it's at the expense of performance. I want to prioritize writing clear code, even if it's at the expense of cleverness. I'm doing it in pure Ruby because Ruby's fun, and I'm doing it with no third-party dependencies because dependencies aren't fun. Before I kick off, I'll just do a brief retro on what happened last time. So this is going to be very brief. I mean, last session I tried to get exports and globals working broadly, with a little bit of imports as well. It wasn't good. I don't feel like I did a great job of any of it, really. Firstly, it was Friday the 13th, so I was clearly set up for failure from the beginning. But also I just sort of got really stuck. I got stuck for ages, found it difficult to make progress in a sort of satisfying or principled way. So it was a bit of a bummer. Really, the heart of the problem was that I don't have any systematic way of dealing with abbreviations in the concrete syntax. And so for the first time, I had to deal with the fact that when you're parsing a global definition or, a function definition or any of the other kinds of definition, really, because you can have inline imports and exports in the form of abbreviations inside the definition, it means that the definition it doesn't just generate that definition in the AST. It can also generate arbitrarily many exports in the AST, or it should do. Or indeed, if it's an import, it doesn't even generate the original thing. If you're importing a global, you're not really defining a new global in this module. You're just referring to one that lives in another module. So that caught me by surprise a little bit. I mean, I did muddle through in the end by sort of accepting the idea that I was going to compromise, basically, that I was just going to sort of hack it together for now, make that compromise, and then come back and finesse it at some later point once more stuff is working. And, that got the test passing. So I still don't feel great about it, but I'm now fairly determined to just roll with that compromise and not let it derail me prematurely. There was a slight temptation in this session to go back and sort of pick that hack apart and try and sort of get rid of it. But I think essentially I've just decided that I'm going to just live with it for now. And then at some later point, I'm going to deal with it. So I think what that means is that that hack is probably going to multiply. Like what I did in the end was I decided that I was just going to store those inline imports and exports, just store them on the definition itself. So rather than actually tackling the problem of how do I generate real imports and exports in the AST, which is really what you're supposed to do, I just decided I'll just stick that information on the definition, and then in all the places where I need to, find all of the imports or find all of the exports or whatever, I'm just going to need to account for the fact that some of them are hidden on these definition nodes, which is not really great. But like I said, I don't want to dwell on it and get sidetracked into rethinking how the AST parser works, because I feel like I've already spent too much time on that and I just want to get on to stuff that's more interesting. So I suppose this is me trying to commit to sticking to that and not allowing myself to sort of get sucked into a big refactoring session and doing that. Oh, hi Chris, welcome. Thanks for joining us. So yeah, that's it. I'm sure at some point I'll come back and find a nicer way to deal with abbreviations. Like in general, it's a more general problem across the whole parser. It's just that until now, it's been easy to deal with those abbreviations ad hoc, and now that's come back to bite me basically. So yeah, I know it's not good. I am fine with that. One day it will be better. That's the thinking, I think. So the only other thing I wanted to mention on the plus side is that actually just today I got some responses from the editor of the WebAssembly specification on the 2 issues that I opened. And they confirmed, after a bit of conversation, they confirmed that the 2 things I reported were errors in the WebAssembly spec. And they have now opened 2 pull requests updating the spec to fix both of those points. So that's really great. It's really nice to, I know several people, including Chris, were saying, well, if you think the spec is wrong, then the spec is probably wrong. But I genuinely just assumed that I'd made some kind of oversight. But yeah, it turns out that there was stuff in the spec that had either sort of drifted out of sync with the executable specification, with the sort of the automated test suite, or it was just a typo or something that had been forgotten in the editing. So it feels good to have, I mean, I didn't really contribute anything, but I did at least pay enough attention to the specification to be able to point at something and say, well, this doesn't make sense. I think it needs fixing. And then to have the editor of the spec come back and say, yes, you're right. Thank you for spotting that problem. We're going to fix it. Here is the fix. It's really good. So, on balance, let's call it even. I feel a little bit, I don't feel great about having to make those compromises in the parser, but I do feel quite good that I've been able to, in some tiny way, participate in the wider sort of community of people who are paying attention to the WebAssembly spec in some form, because that's definitely what I'm doing here. So I think that's probably all I've got to say for now. Why don't I, before I get started, maybe I can just show you those pull requests and stuff so that you can see what I'm talking about. So I think, yes, here we go. So this was the first issue that I opened, I think. Yes, it was. So yeah, this was 2 weeks ago. But now you can see, instead of like 0 comments, now there's 9 comments and maybe fixed by this pull request. So I won't dwell on this, but just very briefly, this was the thing where I was concerned that it wasn't clear whether you were allowed to, well, it was clear because the test shows that you're allowed to reuse a label. So here, there's a label being defined for this block here, and then there's these nested blocks that are redefining that same label. And here there's a branch, and that branch is explicitly supposed to, this test is checking that that branch actually branches out of this block, not out of this enclosing block. And so I sort of complained and said the specification says that this is not allowed because there's this side condition here that says you're not allowed to prepend some new label onto the identifier context unless that label doesn't appear in the existing one. So this side condition is saying you can only add a label to the list of labels if it's not already part of the list of labels. And, this code example in particular made it clear that you were allowed to do that. So we had a bit of a conversation with the editor here. There was a bit of a misunderstanding in the middle here, but what it came down to was that they opened this pull request, which slightly updated. Now this is actually a little bit hard to see. Maybe I think I've got it in, I cloned the repo, which I've already got cloned, but I made a new clone of it specifically for this. What is it? Document core build HTML index. Yeah. So this is my local build of this branch from the pull request. So maybe I can just show you a comparison. So this was what it used to say. Now it says something a bit different. Here it is, labels. I should embiggen this as well. In fact, maybe I can put this side by side. Yes, okay. So that makes it relatively easy to see what's changed. So what's changed is that whereas previously there was just this single, here it was saying syntactically if the label is an identifier, so if it's like $X or something, there's only this one production that applies, and you can only apply it if that label doesn't appear in the list of labels, which meant that there was just it's a syntax error to introduce a label that's already present in the sort of, this is effectively recording the current scope, what labels are currently visible in the current scope. So the change that the editor made was to add another clause in here that says that first one still applies, but then here's a slightly more complicated case that says, well, alternatively, if it's syntactically an identifier and the identifier in question already appears in the list of labels, specifically it appears with the index I, then we form the new identifier context by still adding this label to the front of it, but instead of adding it to the front of the original identifier context, we do this I with labels I equals epsilon. And what that means is we sort of remove, or we replace that label in the current identifier context with effectively with nil. So this is sort of, I don't think this is strictly necessary, but it's a nice way of tidying it up and saying that, like, well, we're adding this label onto the front of the list of labels, but we're also erasing that label from its current position in that list and just replacing it with nil. And it's okay to have nils in that list, because you can see this final case is if there's a label, because labels can just be empty. If you just have a block with no label, then it uses this epsilon clause. And in that case, we do just push an empty label onto this list. So it's saying, like, from the point of view of this new scope that we're in, this label foo that has just been introduced is the nearest label, and there is no other label foo in its ancestors. So even though there was previously a parent scope with a label foo, we sort of remove that from the list of labels. And I think that's a really nice way of dealing with this, a really nice piece of cleanup to say, like, now there are these two cases. Either it's effectively a new label that's never been seen before, and that's the simple case. And then here's the sort of get out of jail clause, which is if we're reusing a label, then we just slightly update. Before we add that onto the front of the identifier context, we sort of modify the existing identifier context to contain nil in that, in the position of the one that was conflicting with it. So, I mean, that just, and then there's this note that's added here that says if a label with the same name already exists, then it is shadowed and the earlier label becomes inaccessible. So effectively, I mean, semantically, i.e., like, according to the execution rules of the programming language, that earlier label was always inaccessible. Like, I don't think there was any way. Well, because this all gets resolved in the identifier context by looking, these labels all get turned into indexes anyway, and the way they get turned into indexes is by looking them up in this list starting at the beginning. Or, well, that's my interpretation of it. Maybe that's not quite right. But yeah, at the very least, it makes it very clear that the earlier label becomes inaccessible, that we essentially sort of splat it out of this list of labels and replace it with nil. So that's kind of cool. I was happy to see that change. Hopefully this pull request will get merged, and that's, that sort of improved the specification a little bit. The other thing was where this is sort of a more technical problem, but this is, well, these are all technical problems, aren't they? But this is an even more technical problem where I was concerned about the fact that in this piece of formality here that shows the identifier context I, so this is the initial context for the module. So this contains the names of all the functions that are defined in the module, and the names of all the globals that are defined in the module, and the names of all the tables that are defined in the module, and all the types and all that kind of stuff. This is sort of an input when you're trying to parse a function definition. And then this identifier context I is actually not used in here, or at least, I'll spare you the details if you've already seen the previous episodes of this or if you've already read the pull request. But basically, I is not used here. And that seems like a mistake because when we're parsing the body of this function definition, we may well need to know things like the names of other functions in this module or the types in this module or the globals in this module. That's exactly the kind of stuff we would need to look up in the identifier context. And the fact that I comes in here, and we synthesize this I double prime from I prime and some other stuff, but I prime just contains the names of all the type use gives you an opportunity to name some of the parameters of the function. And this, what we're adding to I prime is the names of all the locals that are in the function definition. So I double prime here is just an identifier context that tells you the names of all the function parameters and all of its local variables, which is useful, but it's not everything that you need. You also need this I that comes from the module definition that contains all of the other function names, all of the other global names, all of the table names, and so on. So that's what I was complaining about. What is it? Modules.html functions. So the change, again, the editor just said, yeah, you're right. That shouldn't be that way. And so the change was a little bit of a change of wording that I found confusing, but most importantly, a change of this, an update to the mathematics here. Is that the right size? So yeah, this is before, this is after. The only thing that's changed is that in the before, this says I double prime equals I prime composed with the locals. In the updated version, I double prime equals I composed with I prime composed with the locals. So it's a very small change here, but to me, this is the difference between it being wrong and it being right. And you know, when you're trying to read one of these specs and get your head around it, it really helps if it's right. So again, that's kind of a relief for me to see that there. There was also, yeah, I made a little change to the wording here. Possible parameter identifiers. Yeah, it's up here. Yeah, previously with the type use, one thing that made me confused here is that type use is the thing that generates the names of the function parameters. And here it said essentially the type, essentially the identifier context that it produces is the local identifier context containing possible parameter identifiers. Oh, that was the updated version. That's why I was like, well, that sounds right, but that's the updated version. So what it previously said is the updated identifier context, including possible parameter identifiers. And that wording made me believe that there might be a problem here because this initial identifier context I, again, isn't part of what is produced here, but the body makes it, the prose makes it sound like it is. You know, the use of the word updated here and saying including possible parameter identifiers, to me implied that we were supposed to be somehow adding the parameter names to the existing identifier context, and that's not what these rules are doing. It just builds a new identifier context I prime that just contains a single local variable or contains multiple local variables. Well, in fact, it's multiple in both cases, isn't it? Just depending on whether there are names or not. And that wording's been changed here. So now it says, instead of saying the updated identifier context, including possible parameter identifiers, it just says, and the local identifier context containing possible parameter identifiers. So again, I mean, this is language lawyering stuff, right? But I think it's much clearer what the intent is here when you're reading this specification. It's much less likely that you're going to become confused about what's going on here. And it's much more likely that when you read this, the rule for function definitions, you'll just immediately go, oh yeah, I get it. We take the initial identifier context from the module, which is I, then we add in I prime, which is the function parameters, and then we add in the locals, and that's what gives you the identifier context for the function body. That's what you would expect. So I'll shut up about that now because I accept that it's a little bit boring, but it's a small win to have participated in that conversation and to have sort of provoked the improvements to the specification. So I think these two things that were here in blocked, I think I'm just going to check off because these were about those two issues. They haven't been merged yet, but I'm sort of relaxed about the fact that I've got what I wanted out of those conversations, which is some confirmation that my understanding was correct. And hopefully, you know, those PRs will be merged soon. And then this, you know, when the 2.0 final version of the spec comes out, I'm hoping this is going to, you know, those changes will be reflected in it. And so the spec will be a little bit more correct. So that's good. Anyway, back to the WebAssembly mind of trying to get the tests passing. So yeah, I'm just checking that nothing has gone wrong mysteriously since last time. I did add a couple of questions here. I said, should shadowed labels be removed from the labels index space? So this is about that change I just showed where, like, when we introduce a new label, if it already appears in the list of labels, then we remove it. I don't think this actually makes any difference in practice, so there might not be any point in doing that, but that's just something to think about. More general, you know, I just woke up in the middle of the night in a cold sweat thinking like, oh yeah, I think I had to do this compromise. Oh yeah, I was a bit worried about this big failure that was showing up here, but this is part of a pending test, so that's okay. What was I worried about? I was worried about in the interpreter, we had to start tracking the current module. And the reason for that is because when we're inside, yeah, I mean, like when we're inside, let's actually find a place. Yeah, maybe find global. No, okay, so this is the best example. Like, when we're inside and actually evaluating an instruction, we need to know what the current module is. And at the moment, well, because that determines sort of by default, well, I guess what I really want to know here is sort of what the current memory is actually. So that's maybe not a good example either. But the point is, you do need to know, you know, if you want to get a global, what module are you currently in? And at the moment, how do I update this? I suppose maybe I'm thinking ahead here. What I'm worried about is that when we are able to import functions, then when we invoke a function that lives in a different module, I'm not sure how we're going to keep track of this current module business correctly. And it occurred to me that maybe what we should do is when a function gets defined, like just store on the function which module it lives in, and then maybe here when we start invoking a function, we could do like current module equals function.module or something like that. And then at least we'd always know that before we start evaluating the body of a function, we've kind of updated. So, you know, here when we're looking for the correct type and we're looking in the current module, that there's some sense that this function is like bound to a module rather than, I mean, I assume that right now, at some point before we call invoke function, someone will have made sure that current module is set correctly. So here, like in an invoke or in an assert return, we do actually set current module correctly. So yeah, I'm not quite sure about this one. Let's make this like questions I'm unsure about, because I don't think these are things to be done immediately. It's more like stuff I'm not quite sure of. The like, yeah, the to do here is not shadowed objects should be removed. It's like, is it worth doing? I think this is in the same category. Can we expand abbreviations without having to worry about instructions at the same time? So I was this is about, yeah, I'm not going to get distracted by this, but this was a thought about, instead of doing lots of ad hoc abbreviation handling, which is what I'm currently doing, instead I could just have a sort of a preprocessor pass that just all it does is expands abbreviations. And I think maybe well, it would definitely make some things easier, because it would mean that I don't have to worry about all the hacks I did last time. You know, like if it happens that you've got an inline import that effectively makes a global definition or a function definition or something go away because you're not defining a function, you're just importing one from another module, for example, then the preprocessor could just do that replacement as part of the pre-processing, and then by the time it gets to the real parser, there's just an import to deal with, and you don't have to deal with those, you know, there being multiple ways of expressing something, which I think is probably the intent of the specification. But the reason why I've shied away from having these sort of multiple passes is because of the need to understand things like instruction folding and the arity of instructions. So like knowing that certain WebAssembly instructions take a certain number of arguments in order to understand where instructions begin and end. And so this was just me thinking about, is there a way that you could, if all the problematic abbreviations were in places where instructions can't appear, you know, if they're just module fields where you're just doing, you know, a function definition or a global variable definition or whatever, and you're not concerned about abbreviations inside a function body, for example, or inside the initializer of a global variable, if you're just going to ignore those and expand abbreviations outside of the places where arbitrary expressions can appear, that might dramatically simplify the problem. And you might just be able to say, well, if there are instructions in a list somewhere, I'm just not going to touch that because I don't want to have to understand them. But anything that's straightforward to understand, like a function definition minus its body, yeah, I will go ahead and expand any abbreviations I find in that. So that was the idea there. I don't know the answer, and I'm not going to think about it right now. I think everything else here is just what was here before. Yeah, I mean, there's sort of various other complaints about exporting and abbreviations and stuff down here, but I think this things I could do next list has rapidly degenerated into just a junk drawer of stuff that could be better rather than actual tasks for me to do this time. So I'm going to not entirely ignore it, but I'm not just going to do what that says. I think what I'm going to do for this session is focus on what tests are currently pending, and what other tests could I be looking at either in addition to these ones or instead of these ones. Well, firstly, I can see here that I've actually, last time I managed to add exports and global to the list of tests that were passing, so I can remove exports and global from here. Names and func pointers are currently pending. So I remember I did this sort of cheeky hack to support the idea of importing a global from this spectest module, which was, let me find it, in here. So this is not an official part of the specification, but the reality is that the reference interpreter defines this special module called spectest that's got all this stuff in it. And I don't have proper support for being able to import modules yet. But I sort of hard-coded the idea that if you're trying to import a global from a module called spectest, then its value is going to be 666 because, again, in the implementation, it doesn't say here, but in the implementation of this interpreter, all of these have got the value 666. So I sort of bodged that in to make it work, but I think these tests probably need something a bit more, well, they definitely need something a bit more comprehensive than that because they're currently not passing. So let's, is it run WAST now? So let's just check in. I don't know if I tested this last time, but let's just double check. Well, in fact, I think when I ran the tests, well, I was going to say, I think we saw these fail. So yeah, that's names failing. Oh, and of course, if they hadn't, I would have heard about it because the test script would have said unexpectedly passed. Okay, yeah, so both of those are broken. They're both complaining about the fact that there's an import. So maybe that's something I can start looking at now, is like, whereas I think the, whether it was global.wast or one of the other ones. The one that was using the global import of the import of a global from the spectest module, it was doing an inline import rather than like a top level import. But I think that here, because this is, I don't know exactly where this is appearing, sorry, but somewhere there's an import that it doesn't understand. So I could maybe take a look at that. So these two are still failing as expected. BR table, it says needs ref extern, which I think I have implemented. It's like a dummy implementation. Yeah, I don't really know how you're supposed to deal with this, but I did do a dummy implementation. So let me just check, because I don't think I did check this. BR table. Oh yeah, okay. Well, turns out BR table's working, so I can just, I'll just go ahead and add that. Yeah, it's not already there. Okay. Let's make another tab here. Add BR table.wast to parsing tests. I think this was only failing because ref extern wasn't implemented yet, but we now have a dummy ref extern implementation, which is apparently enough to make all the unskipped assertions in this file parse. Okay, so I can get rid of that. Let's just check on the rest of these. You know, this list is whittling down. Data.wast is not working. So this was import. This was import somewhere. At the moment, this one is complaining about offset. I don't know what that is. Let's check this. And also, you know, just bear in mind that this list of tests was just one that I conjured out of thin air. Like I just picked some things that sounded like they were related to stuff that we'd already implemented. I don't have any expectation that those are necessarily all going to work or anything. So I don't have to stick to this list of tests. This was just a sort of finger in the air. I reckon I can probably make some of these pass. But so far that seems to be going okay. Okay. This is like some problem with identifier context. It looks like, because it's trying to look up, well, the index space here is nil. So it's trying to look up some identifier in a part of the identifier context that isn't implemented yet. So that's something that I could probably fix. Bulk.wast needs memory.fill. I don't think I've implemented that yet. I've gone too far. Unhandled exception. So yeah, I think this is just a, you know, there's some kind of parser problem. So this was parse import. This was parse offset. A mystery parser problem. And then this one, it says needs proper LM support, which I don't think I've implemented. So yeah, this doesn't even parse. Parse LM. Okay. Well, these are probably all tractable, so I can just have a look. I've already got, so you know, I've already had got one parsing for free. That was easy. I've got names and func pointers here, so maybe it would be beneficial to start off by looking at those, given that for whatever reason I chose to put them in pending before, so I must have at some point believed that they were closer to already parsing than other stuff. So let's take a look at this. Names.wast. Firstly, what even is this? Okay, let's GitHub warning about bidirectional Unicode. So I'm not quite sure what it means by names here, but clearly it's maybe it's this bit seems like it's about exported function names. So maybe this whole file is just testing what names can things have. We're certainly looking at function names for right now. So yeah, it looks like it's testing all sorts of properties of Unicode, which hopefully aren't gonna. Oh god, I mean, I hope that UTF-8 string equality in Ruby is going to take care of all of these things. But who knows? Oh, there's some Zalgo, Tony the Pony stuff going on here. Okay, so this is all about function names. Oh yeah, maybe that's it. Oh, that's it. It's just about making sure that various exotic function names actually work. So it looks like they've gone through and sort of stress tested the parser in the presence of various, bits of Unicode weirdness that make GitHub add this annotation in the gutter saying there's Unicode weirdness going on here, and just trying to make it work. So where is our problem? Files like this always make me a bit nervous because they're quite difficult to edit, especially when you've got unprintable characters and things like that. It can be a real pain to, if I decided I wanted to whittle this file down to make a minimal reproduction of whatever the problem is, that might actually be a little bit difficult. But then again, maybe Vim has got my back. So it was complaining about import. I think it's probably this sort of top level import that's causing the problem. Although I don't know if that's where the exception was coming from. Let's just see. Yeah, I was sort of surprised that it was coming from inside parse normal instruction. Let's just drop some debugging code into the parser for a second. And let's say parsing S expression, quicker to type it, inspect, and just to keep an eye on what it's trying to parse at that point. Parsing import spectest print I32. Yeah, well, as expected. I don't really understand. Oh, I think perhaps it's this one. Yeah, I was going to say I don't understand why this is being sent to parse normal instruction, but I think it's actually this, because I assume it's treating this as the function body essentially, which it isn't. This is right at the bottom though. So just out of interest, I mean, what I really want to know is what this is the same question that this whole test is trying to ask, which is, does your implementation correctly deal with all of these weird Unicode characters in the correct way? So, not weird, but like intentionally pathological cases, which it seems like some of these are designed to provoke. So this is dealing with sort of like normalization edge cases. There were like some combining characters and yeah, font variations, just all kinds of unusual stuff in here. So yeah, control codes. So let me just try spec test core names. Let's just try copying that here. See if Vim can cope with it. You would hope. And then we just snip off that last bit that was causing the problem. So now, if I run this local copy of it, okay, great. Well, that's good news. It means that everything apart from this bit at the end is working. All of these assertions are passing. I mean, I shouldn't be particularly surprised. This just means that, you know, Ruby's UTF-8 support works, which is a relief, but, you know, I've previously been burned by the expectation that Ruby's floating point number implementation works, which it does in its own way, but that's different from the way that WebAssembly expects it to work, or indeed its integer implementation and things like division. So this was not a foregone conclusion necessarily, in my mind. I think that's enough caveats. So it's a relief that those are all passing. So now I just have to find a way to smuggle this through. So essentially this is... what's this saying? So, yes. So, sorry, I'm just understanding what this print32 function is doing, but it feels like it's not quite in the same ballpark as all of the rest of these things, because what this is doing is checking that you can do an unabbreviated import, which is to say a top level import, which is going to define function 0 in the module. So this defines the 0th function by importing this, again, from this spectest module, importing this print i32 function, which I haven't got an implementation of. And then here, by doing an inline, so this is using an abbreviation inside a function definition, re-importing that same function as the 1th function in this module. So the 0th function is this like top level import of print i32. The 1th function is this inline import of that same function, but it's going to be treated separately. So now function 0 and function 1 are both this imported print i32 function. Then we're defining function 2 in the module. Again, like none of these have got names, so this is anonymous. So function 2 is one that just calls function 0 with whatever the first parameter is, and this one calls function 1 with whatever the second parameter is. So this is gonna, you call this function 2, you call it with 2 arguments, and it calls functions 0 and 1 with those 2 arguments respectively, and both of those are print i32. So this just prints out its 2 arguments basically, but in a contrived way. And then we finally got this function called print32 that just calls function 2. Oh, sorry. So this is an export. I just wasn't reading it properly. This is exporting function 2 under the name print32. So it's not an abbreviation. In fact, I don't know if we've got support for this yet. The idea that you can, yeah, just having a top level export of a specific function, I don't think is implemented yet. So, although actually, maybe I did implement that. Maybe that was the sort of workaround that I was talking about before. Oh, it's in the interpreter, isn't it? That's it, exported names. Yeah, so I have got this. Yeah, sorry, I'd forgotten about this. So, yeah, we do have support for this, I think. Yeah. So we sort of look through this is the hack where some of the inline exports are just stored on the function AST nodes directly, and then if we don't find that function by looking in that hack place, we actually do look at the top level exports in the module and try to find the function. I've used a pinned local variable here in this pattern match to find specifically a function export whose name matches what we were looking for. So I think we do support that, although let's just see, how does that exports get populated? exports equals mod.exports. Well, that's not very good, is it? How does that get populated? So it's parse export. Parse index context.functions. Oh, okay. Well, maybe that's all. Maybe that's all okay. Because all that this export can contain is an index, and that's what it does, is it looks up that index in the list of functions in the module, and here that index would be 2. So actually, it looks like I've done everything. I'd sort of forgotten that I got this working, but I guess this is what I must have done in the depths of my misery last time I streamed, was actually, this was part of what I got working, was all of this kind of stuff. I guess one of the other tests required this. I can't believe I've already forgotten that, but I think my brain has just ejected those memories because they were not happy ones, but I clearly did get it working. So all of that is to say, I think the only part of this that's, well, I think these 2 lines are problematic, basically. Right now, the problem is that I don't think this even parses, but once it does parse, I don't know if either of these, especially this one, will actually be registering a function definition, which it has to do to make all of this work. Although, saying that, this assert return here isn't comparing the return value to anything. Like, this function here that it's calling doesn't have any results. It just has this side effect of calling print I32 twice in a contrived way. So, I mean, unfortunately, the direction my brain's going in is like, how little of this do I need to actually implement? Like, for example, it just doesn't matter whether I actually print these out. Like, print I32 is supposed to print out its argument somehow, but A, I don't want it to, because I don't want junk on my terminal when I run the tests. And B, there's no way for this assertion to know whether that's actually happened or not. Like, it's not making an assertion about what happens on standard out when this function is invoked. It's just checking that, well, like any assertion, one of the implicit things it's asserting is that this evaluates successfully, that you can, that you can call print 32 with some arguments and it doesn't break anything. So this is another situation where I think I already had a complaint here about open a PR to replace assert return with invoke. This is another situation where I think really, yeah, let's give it a nice safe permalink. This is another case where I think it should probably just be invoke, because we don't actually care about the return value. Whereas in all these cases, we are actually comparing it against something. So, right. So unfortunately, I think I've got to start in the parser as usual. So we shouldn't even be here. We're not even supposed to be here today. It's treating this as the function body, which is just not right. So let's have a look in parse function. This should really be parse function definition, but that is what function is. So here we look for, oh yeah, I remember this. It's this same business that I've got in various other places, where it's like, in parse global, we look to see, we've got a loop that looks for exports, and we've got that here as well. So if there are exports, we just read, we repeatedly read more and more of them, and like I say, just stick them onto this kind of cheeky inline exported names attribute that then gets just stored on the AST node. So that's the hack for exports. But in other places like Parse Global, where we've needed to also deal with imports, there's a similar, I've done a similar hack where it's like, well, this global has actually, effectively, is actually not defined here. It's being imported from somewhere else. And that's what this does. So this can read list starting, well, let's just look for starting with import. Okay, so this is the only place I've done this. Where are all the places that I mentioned import? So this is when we're parsing. Right, so right now, this is the thing. So we're going to need to do something here, because this thing here will just happily throw away this function definition. And that's not going to work, because we need to have we need to have two functions at indexes 0 and 1 for this thing to call and for this to be function 2. So this won't all work if we're just ignoring the import here. So there has to be something here that's kind of comparable to what parse export does. This is building the initial identifier context. And actually, I think that in this case, that's probably the right thing to do, because I don't think that imports affect the initial identifier context at all. Let's just check. Oh, no, they do. Okay, yeah, sorry. It's exports that don't affect it. So this is the right thing to do, of course. I mean, that's obvious, isn't it? I just didn't think. Exports don't change the names that are visible inside the module, whereas the whole point of imports is that they are importing stuff from elsewhere. So although these IDs are optional, and actually in this case, it doesn't associate an ID with this function, so that's fine. But at some point, we're going to have to, what's the right thing here? Add imported function, well, it's like func table memory global names to context. In fact, I think it can only be one. But I think for this, I can get away with not doing that. Okay, where else are we? All right, this is what I was just looking at in Parse Global. Okay, that was it. Okay. So let me sort this out. So this is something like, yeah, add. Oh no, I'm gonna have to deal with this immediately, so there's no point in me. There's no point in me writing a description there, because I'm literally about to do it. But what I can do is just paste in. So this is the thing from Parse Global that can deal with. So let's just go to it. But I think it's the same syntax as global. Because this is dealing with the abbreviated syntax for doing like inline imports in a function definition. So here we go. Abbreviations. Functions can be defined as imports or exports inline. Okay, we're worried about imports. So let's just sense check this. So we read func, we read an optional function ID, and then, well, let's just look at the import case because export is already dealt with. So function keyword, then an ID optional, import name1, name2. So that's what we do. Import module name, import name, right? That's what name1 and name2 is. So we've read that whole thing. And then here, this is doing parse global type. So why was that? Just remind myself why that is the case. Okay, so without abbreviations, you get global, optional ID, then a global type, and then this sort of initializer expression. And that's the else case here, is like, if there wasn't an import, then we have to do what the unabbreviated form is doing. But if you're using an abbreviation, we just parse the global type and then not the initializer expression, because you don't need to initialize the global because it lives in another module. So you're not actually defining it here, you're just referencing it. So how does that compare to function imports? So yeah, function imports are quite complicated. You've got an ID, you've got a type use, you've got 0 or more locals, and then you've got the function body. So if it's an import, so that's essentially, you know, this is going to be like parse normal function definition. I might as well get rid of these. So what's the difference? Again, this is something that if there was just a preprocessor that could turn one into the other, then I wouldn't have to be thinking about this. But this is exactly the thing that I said I was at the beginning, that I've just accepted that I'm just going to have to eat the complexity of this in the short term in order to dodge actually solving the more general problem, because I think that's going to waste a bunch of my time. Of course, and we know that this is I double prime equals I composed I prime composed locals, but we'll save that for a later release of the WebAssembly 2.0's draft specification. So hold on, let me focus on this. Func ID, they're the same. Exports we've already dealt with. Now, if we hit import at this point, so that is the right place that we're checking it, we need to read name1, name2, and then only type use. Because that's what imports need, apparently. Function ID and the type use. And I mean, here we were just throwing the global type away. In fact, in both of these cases, we were just throwing it away, but we were just parsing it to get rid of it. So this needs to be parse type use, which I can see is down here. So I think this is going to be the sort of, here's the rest of it. Oh God. Do I need to think about... No, I don't need to think about updating the... I was just thinking like this business here about that's coming up with a new identifier context with the new type definitions and stuff like that. Oh God, maybe I do need to do that. Okay, hold on a second. So when you import a function, you do have to state for the record what its type is. I think that's what this is saying, is that you can't just say import a function foo and then like not say what its type is. Okay, I think okay, hold on. Yeah, unfortunately, I think we are going to have to deal with this because for each function, I think in the interpreter, we do need to know how many arguments it takes and how many results it has. At least in the case where why do we care about that? I mean, basically, yeah, like when the function is called. Oops. So we need to know. We need to know the type of the function to be able to, and that type needs to be in the types for the current module. So for this to work, for all the pieces to fit together, when we're parsing, well, actually either of these, oh God, what a pain. When we're parsing either of these, but especially this one, well, in the currently we're worrying about this one, so that's why especially. We need to add basically this function definition, even though it's an imported function, we still have to store an index to the type of that function. And so that means that we have to add this type to the identifier context if it's not already there, so that we can point at it. So that work is already all done here. Okay, look, that was too much talking. What I'm going to do is just paste this in here. So actually, here I'm going to say to do add well, what we need to do is add type to identifier context. But is that what parse type use does? Yes, it does. So we'll actually get that for free. In fact, maybe this isn't too difficult, because parse type use already updates the identifier context. This update here this could actually be made clearer now that I think about it. So let's say, how do I do that? Yeah. L, yeah. Something like make parse type use return a context containing only the parameter names, i.e. like the fixed spec now does. So explicitly return a context containing only the parameters, i.e. like the fixed spec now does, rather than have the side effect of modifying the current identifier context. And that will allow us to make this be the only place where we update the identifier context, and we do it by composing together all of the pieces up here rather than doing it down here. So yeah, okay, I'll come back to that in a minute. But for now, so what did I want to say here? Well, actually, maybe this is just... I mean, if there are any parameter names here, I think they're irrelevant. Yeah. No one cares in an import like this. Well, let's look at imports. So here we've got a type use. Yeah, no one cares. No one cares about I prime, I guess is what I'm saying. The I prime contains all the parameter names from type use. Like that's what this says, is that when you've got a type use that's got a bunch of parameter names, those get stuck into this I prime. This is just a context that just contains the new parameter names from the type that you've written down, but that just gets thrown away here. We just remember that there was a function yes, and the type use here, x, is the index of the type. So we don't care about parameter names here. So I'd be tempted to do that to make it clear that we're ignoring it. And maybe that's it. So actually, even though I was making all sorts of pained noises about this, maybe that's fine. If there's an import, then we have to read these names and remember them. We need the type index because that's an essential ingredient in the function, which does get inserted here. But basically, the list of locals... Why do we need that? Why do we need the list of local names? I'm not sure. Oh, are those just types? Yeah. Again, that could be clearer. So what do we use that for? Is this a situation where all we actually care about is how many there are? Function.locals. Yes. So yeah, that's another situation where, like, right now, that's not important. And they don't exist in this import form. So yeah, we just, the locals and body are only going to be populated if we're not importing the function, which is just like for globals, the initialization expression only gets set if it's not an imported global. Yes, and this is just about parsing the function body and updating the context. Yeah, we don't care about any of this. So I think maybe that's enough. Read the import. Oh, but we also need to actually remember it here. Maybe here. So yeah, I was like looking for some kind of reference for whether that should become come before or after the exported names. The thing is that syntactically, you can have multiple, you can have export, 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 and then import. That's what these two abbreviations imply. So I guess I'll have the exported names first, and then I'll have the import there, and then the AST will need the function. We'll need to have import here. So again, a place where we can stash that information about the fact that this is actually an imported function, which makes me feel a little bit gross, but I'm just gonna not think about that in the interest of getting work done. So let's just see. Okay, so I haven't broken anything. Let's copy it again and run the whole thing. Okay, so the good news is that it parsed correctly. The bad news is it couldn't find the function print32. Okay, so let's have a look. Well, that will be because, hold on, what's it trying to find? So it's trying to invoke print32. It should be able to find that. Because that's an exported function. Oh, hi, Packrat. It sounds like you're leaving, but yeah, thanks for dropping by, and I'm glad you're enjoying it. I'll see you next time, hopefully. So what's happening here? It hasn't been able to find print32, which is unexpected because that function is exported down here. So I'm sort of loath to commit any of the stuff I've done yet because I haven't seen it work. I mean, I've seen it parse successfully. Is there some sense in which I could just add the parsing bits? Yeah, I think there is. So let's not do that for now. Let's just do that bit. So I think this is something like, well, let's have a look. So this is, yeah, that's not trying to parse it, that's storing it. Okay, let's try instead. L parse global. Okay. Okay, so I think maybe this import stuff, yeah, this sort of predates this round of changes, I think. So I was just looking for something I could copy as a commit message, but let's just say parse import abbreviation in function definitions. And then I can just say this information isn't stored anywhere yet, but this allows the parser to succeed when parsing, e.g. names.last. Let's just check that's true. Yes, that is true. Okay, cool. Okay, and then I guess I can add this. So I did see this here. So this is store import information on functions. That's just adding it to the AST basically. So yeah, I guess I was confident enough to commit that. I think something like that is obviously going to be necessary. So the exception here, line 226. So it's here. We can't find it. So let's say okay, I was just checking I didn't commit my debug code, but I don't think I did. So let's say looking for function name.inspect in let's see current module. So let's just see what that looks like. Oh. Okay, well, that's tons of junk, and I guess this is all of those previous function invocations. So we say looking for function print32 in. So, I mean, obviously this isn't going to be working just yet, but I was expecting a different failure message than this is the point, because the export should be working. So here we say exports name equals print32, kind equals func, index equals 2. So what's the prob, Bob? So clearly this is going to fail, and we end up in here. So let's say found current export in current module exports detect. Current module exports inspect, sorry. I was reading the line up there. Okay. So we go, looking for function print32, found current export in blah, and its name is this. Oh, I wasn't reading. I wasn't reading. So, okay, yeah, this is what we would expect. I'm sorry. I should just pay attention to the error. All of this lookup stuff works fine. It's this. It's looking in, let's say, looking for function with index export.index in current module functions. That's where the problem is because the 2 is out of range because this isn't doing anything. So that is actually exactly the problem I was expecting to see. It's just that I didn't think about it. Looking function with index 2 in, so this first one is this import spectest. Locals nil, body nil, yeah, that's fine. And then we're just going to need to, at some point, we're going to need to implement the idea of invoking a function like this that doesn't have any locals or a body, but does have an import. And again, I think I'm just going to, for now, I'm just going to hack this in with a condition that says, well, if the import is spectest and it's a function name that we recognize, then just make it a no-op. You know, I don't want to print something out. I just want to make it a no-op because I don't want to see the output of this function. I'm becoming increasingly annoyed with these unescaped strings. Yeah, it's this thing. We should be parsing it as a quoted string. So maybe I'll deal with this in a minute. Well, once I've got the test parsing, I think this is overdue to be sorted out because it's silly seeing these these strings that have been read from the source code and they still contain the quotes around them. The parser already knows how to deal with those, and it's just pure laziness that's resulted in me not dealing with that in the parser. So, okay, so actually everything is working. Everything is failing correctly, which is that there are, I believe, 2 function definitions here. There's this first one that is the one with the inline import, and then there's this second one. So index is 0 and 1 essentially, and here you can see it's a local get instruction, a call instruction, another local get instruction, another call instruction, which is exactly when we unfold these folded expressions, that is exactly what we get. So that is all correct. What is not correct is that I haven't implemented this. At the moment, this doesn't generate a function definition. And I suppose what I'm going to do is the same as what I've done with exports. The thing is, I've really dug a hole for myself here because it doesn't really make sense to have these, given that I've said, oh, we're just going to squirrel away. Well, no, I understand why I've done this. You know, this function definition has got a spot for me to write into it that it's being exported under this name. But I'm not doing that. I'm storing these exports separately. So it means I've got this clumsy situation where first we look through all of the function definitions and check their sort of inline exported names. And then we check through these sort of explicit exports, looking for something of kind func with the name we were looking for. And it's just sort of silly because I could have just stored that exported name on the function itself. But the thing is that it's this part that's the hack. I really want to stop doing this and just have it work in this way. I want, when I parse a function definition that has an export in it, I really want to arrange for that to update the module's exports rather than squirrel it away on the function. So I think if the fact that this is a bit lopsided and cack-handed is a problem, but I think I'd be making the problem worse if I got rid of these explicit exports and said, oh, well, look, I'm gonna make the parser, when it finds an export like this, it's just going to reach into the appropriate function and update its exported names. because that's moving me away from where I want to be, which is in the opposite direction, to have only this mechanism and get rid of this idea of, well, first you search through all the functions to check their exported names. So I'm going to resist the urge to do that for now and just keep maintaining. Well, basically, I'm going to need to do the same thing here, aren't I? What's the right thing to do here? I mean, it's not part of this, because this find function is only looking up in a module. I mean, actually, there's no reason this needs to be, there's no reason this can't be parameterized on a module. Yeah, I think I'm going to clean this up a little bit, actually. I'm going to add a parameter to this and call it mod. And all of this in fact, this could just be on module objects, couldn't it? Yeah, I think that's probably where this should go. But let's... No, sorry, this is I've got distracted by an attractive nuisance that's something that I know how to fix. So let's say make find function take an explicit mod argument rather than expecting self.current module to have been assigned. And then here is like move find function and probably find global onto the module class, and then rename to find exported function. Find exported global. Like, just make it much clearer that what we're doing here is, because there's two categories of names for function. There's sort of the internal names that have an ID, and actually those don't exist at runtime anymore. So that's why I didn't bother to make it clear. And maybe I shouldn't, but like, I think it probably does make it clearer that these are, we're asking a module to look into its exports and find this function or find this global or whatever. Anyway, yeah, okay, so I'll come back and do that after I've got everything working, not before. So what I need to do is nothing to do with this function. What I need to do is make sure that when I find this import, that this essentially generates a function definition. Or it generates explicit imports the same way that exports do. And again, I think I should probably be consistent, shouldn't I? Because I assume that when we look in here, the imports are going to generate, yeah, this is like an import record that tracks, whereas exports, when you export something, it records, is it a function or a table or a memory or a global? Like, what name are you exporting it under, and then what kind of thing are you exporting? It makes me realize that here there's no, where does the index come from? Oh yeah, it just doesn't appear in this pattern match, but yes, it does also have an index. So essentially an export has got the name being exported, the kind of thing that's being exported. Is it a func or a table or a memory or a global? And then the index of the thing that's being exported. Imports have more than that. Is that right? Let me just open both of these. So exports, yeah, I should be looking to the right of the double arrow because this is the synthesized attribute of this production. So it says when we find an export, we generate, this is effectively the representation of an export, which is the name of the thing being exported and then the description, and the description is just one of these 4 things, right? For imports, we record, right, the module that we're importing from, the name of the thing that we're importing, and the description, which is one of these 4 things. So it's a pretty similar setup. And so I think I should try to resist the temptation to do what I was just sort of narrating I was going to do, which is just generate a normal function definition that's marked as being an import like this one will be. But I think I'm going to resist that temptation and say, like, this is what I should ideally be doing, is synthesizing one of these import records, and this is my opportunity to actually implement that properly. So let's do that. So right now, we don't even have imports, but the reason I'm sighing so dramatically is that I now realize that it's not going to work to have all of these module fields segregated out like this, because you can interleave imports with other kinds of field, and the position where the import happens will affect what the index of the imported thing is. So the fact that this import comes before these 2 explicit function definitions means that the imported function here has to be at index 0, and then this function definition is at index 1. Well, actually, no, maybe, no, sorry. That's not true. Well, everything I said is true, but actually the parser can sort this out, can't it? I think by the time we get here, it's probably okay. I just need to have... I'm just going to sketch out how I think this should work. I mean, effectively, exports don't matter here. How am I going to deal with this? Because right now, the expectation is that you can just do this. If you want to look up a module, a function with a particular index, you just pick up the nth function from the list of all the modules functions. But at the moment, the list of the modules functions are just these 2. And this doesn't even appear in it because this isn't a function definition, or at least it doesn't, we're not treating it as one. And I mean, we're just ignoring it at the moment. So, wow, already feeling sleepy. It's only 9:30. So I feel a little bit torn here. Could the functions know their index? Like, does that make sense? You know, what I'm thinking about is when we come to look up a function, you know, here when I'm looking for function 2, if we, and I think we can see this statically, you know, if the parser recorded that this is function number 2, then it could just look it up. It doesn't matter what position it is in the array of function definitions, because actually this would only be at index 1 in the array of function definitions. But if the parser has told it that its index is 2, then we can just look it up on that basis, and then it doesn't matter. In the list of imports, we could just record that this is importing, and again, the parser knows this is importing function 0. I mean, effectively what we'd be saying is that the parser would just keep a counter of how many functions have been defined so far, and that counter gets incremented either when we import a function or when we explicitly define one. I'm a little bit curious how this works. I'm a little bit curious how this works with the operational semantics, because how do you look up the nth function in a module, basically? Let's see what it says. So it seems like the most relevant instruction would be, you know, a function call. Oh, it says function calls, but I think yeah, cool. So it says turn call x into invoke a if f module function addresses of x is equal to a. So what's this? A module instance is the runtime representation of a module, right? So this is effectively my module class in the interpreter. It's created by instantiating a module and collects runtime representations of all entities that are imported, defined, or exported by the module. So it's got this function addresses. Function instances, table instances, memory instances, global instances, references with an indirection through their respective addresses in the store. So how are function indexes mapped onto so it must be during function instantiation it is organized such that these function addresses, this function addresses array is populated with the function pointers in the right order. So I guess it's module instantiation that I mean, this isn't super important. I'm just curious about how they deal with this to see whether there's some clever idea that I haven't thought of, but I think this is a little bit too complicated for me to read it now and understand it. Okay, well, this isn't very interesting, is it? All right, I'll abort that mission and just think about how I want to make it work. At some point, I would like to, maybe offline, I will read that part of the specification and try and understand how. Because I know I'm not being very articulate here, but the index of the functions are not being preserved here. Like there's no information being stored about there's no information being stored about like, well, what's the index of this function being imported. And a module is just this sort of sequence of fields. Okay, well, I'm going to stop getting distracted by that. I'm just going to think about like, how do I want to make this work? So I need to remember that this is importing a function at index 0, and this is importing a function at index 1, and so on. The thing I'm thinking about is whether I want the parser to deal with that or if the interpreter should deal with it. I mean, what does this say? What is the structure of a module in the sort of abstract syntax? How is it represented? So it is segregated out into okay, so like I think this is the thing I don't understand is like how if a module, if in the abstract syntax a module is represented as these sort of, this is a record and it's sort of segregated out into like, well, you've got your vector of functions and you've got your vector of imports. Like, how are you able to dereference a function index? How do you know whether index 0 or index 2 in this case, how do you know if that's pointing to an actual function or to an import? I don't understand. Every import defines an index in the respective index space. Oh, look! I found the answer. I was not expecting that. It turns out that by reading enough of the spec, I can actually find the answer, which is that order doesn't matter. Oh. Well, I'm glad I didn't go any further trying to deal with that. Right, this is the magical sentence. In each index space, so this means, let's think about functions. So in the function index space, the indices of imports go before the first index of any definition contained in the module itself. So what that means is, it doesn't matter where this import goes. It could go at the end. This would still be defining function 0 because it's an import. And this is always going to be defining function 1, regardless of whether if you permuted its position with the import, because the functions defined inside the module always come after the ones that are imported. And that's a huge relief because it means I don't have to worry about any of the stuff that I just started to worry about. And I guess that's why I couldn't see any information about it. So that's why the functions and the imports don't need to carry that index value. I'm really glad that I didn't jump through all the hoops of adding that, because it is not necessary. All we need to do is account for the number of imports when we're trying to look up a function. Each import defines an index in the respective index space. In each index space, the indices of imports go before the first index of any definition contained in the module itself. So does that, like, this is in the structure. Does that get mentioned in here anywhere? So let's see what this says. Composition of modules. I'm not sure what this means. When would you compose two modules? Oh. Right. So what this is saying... Oh God, okay. So what this is saying is that when you're parsing a module, what you actually do is parse each of the fields individually, and then you sort of compose them all together. And parsing any individual field gives you a little singleton module containing only... It's still a module record, but it just contains that one field. And then you compose them all end to end to get the complete module. And this is... There's a restriction here. So either when you're composing two modules together, either the first one has all empty empty functions, empty tables, empty memories, and empty globals. So those are the things that can be imported. So either the first one doesn't have any of those, or the second one doesn't have any imports. So actually, this is a bit subtle, but what this is saying is that this is forcing all the imports to go syntactically at the beginning. So actually, you're not allowed... So yeah, the second condition enforces... Yeah, this is just what it says. The second condition enforces that all imports must occur before any regular definition of a function table, memory, or global, thereby maintaining the ordering of the respective index spaces. So let's think about... well, it's not going to be a problem here. I was going to say, let's think about how the identifier context gets set up, because what this means is that the initial, I'm sure it says that further down, and yeah, in fact, I know it does. So yeah, okay. So I'm sorry, I'm jumping around a lot here, but this is actually the first time I've thought about any of this, and now I'm starting to understand the meaning of when you put imports in. So it's important that when you have an import here, which could actually give a name to this function. Right now it doesn't, but it could give it a name. That name has to go into the function index space of the initial context. So that will be at position 0. And then if this had a name, that would be at position 1. And if this had a name, it would be at position 2. So I'm not having to worry about names at the moment, but I'm going to have to put something here that says, per the spec, make sure that import func foo adds foo to the function's index space of the identifier context, so that function identifiers get converted to indexes correctly. Ditto for globals. Memories, tables. So I am going to have to worry about that at some point, but I don't have to worry about it right now. I just need to make sure that the interpreter has the correct semantics with respect to what does this to mean. It actually doesn't mean the tooth function definition in this module. It means the two, rather than the tooth, the second, it means 2 minus however many imports there were. Yes. Well, if this was 0, it means the first import. If it was 1, it means the first function definition, because there was 1 import, and so index 1 is going to be the 0th function definition. So yeah, at the point where we look up functions by index, we have to defer to first check all of the imported functions and then check all of the defined functions. So yeah, all of this complexity would go away if I just when I parse this, if I just synthesize this basically. But I'm not going to do that because, like I said, it should be the other way around. So let's think about... I'm sorry, I shouldn't be so... This isn't as big a facepalm situation as I'm making out. It's hurting my head a little bit. So basically, all of these places, well, all 3 of them. Okay, look, this needs to be some function called foo that does current module dot functions dot slice, basically. So let's give it an index, or it's going to raise. Okay. I'm thinking ahead to how am I even going to represent these imported functions, but I think that's a problem for 2 minutes time and not right now. So this is going to be foo export index, export.index. This is going to be foo. Don't need these raises anymore. you know, arguably I should have done this already. So that's, yeah, I mean, basically I need to, if I'm going to have some kind of wonky representation of an imported, of an import here, I invoke function has to be able to recognize it, that's all. But otherwise it's not going to be a big deal. So let me just check that I haven't massively broken anything there. Oh, yeah, I have. I am going to need that in a minute, but it doesn't make any sense right now. So that was quite, I realized there was a lot of talking and face palming and looking at the spec there, but I have learned something important. Yet another detail that I'd failed to engage with before, which is like, how are imports supported? And the answer is they always have to go at the beginning of a module, and therefore they always take up the early indexes inside the module, which I didn't know before. I just sort of invented from whole cloth this idea that you could interleave them with function definitions, and they take up, they sort of assume the interleaved indexes of those functions. But nope, that is not how it works in WebAssembly, which is a bit of a relief. Okay, so it looks like I've successfully extracted foo, and this is going to have the same character as this sort of find exported function, right? This is going to be something like find function. Well, it's almost like get function. That's not a great name, is it? Why don't I call it function at index? It's a sort of slightly small talky. You know, I don't know. I never really know if this was the intention of keyword arguments, but it does remind me of, like, in Smalltalk, you can, or like Objective-C or whatever, you can kind of make the arguments like part of the method name. Because really I want the function to be like function at index, and I could just make that, I could just call it that. But for some reason I've decided to do this. I don't know why. It doesn't really make sense, does it? I think that's okay. I've seen worse than that. Okay, so I think those were all of the occurrences of foo. Where do I want it to go? That's not very good. Maybe there is okay. I don't understand why it's okay for export to be nil here. It doesn't really seem like that should be allowed, does it? Let me just, I just want to understand that. I know it's not germane for what we're doing right now. It's obviously a problem. Where is it? Oh. Right. Yes. It's this one case where we're not able to resolve it because there is no export here because we don't understand this binary format. So that's the one. Well, because when we find the function, we're able to detect that and gracefully skip you know, to do raise. What should we say here? I'll just put a comment here temporarily. Unless export nil. Let's say to do remove once binary format is supported, and I'll do the same down here. Because that's just going to be an attractive nuisance. I will notice that again, I think. So what do I actually want to add here? This is turning into a bit of a to-do fest, isn't it? Let's get rid of the to-do here for a moment. Yeah, that's what I want. Yep. So yeah, now we've encapsulated all, because I wasn't, I'm sorry, as usual, I'm being completely inarticulate. The reason why I'm extracting this function in the first place is because I want to encapsulate this access to the list of functions, because I've now learned that the interpretation of the index is more subtle than just look it up at that index in the list of functions. It actually needs to be looked up. We need to, for my purposes, what I need to know is this index going to land us on an import, or is it going to land us on a function that is actually defined inside the module? And right now, we don't have a representation of imports, but once we do, this is going to need some logic in it, which is like, oh, if this is indexing into the, basically, if this index is within the list of imported functions, then return some kind of representation of an imported function. I don't know what the heck that's going to look like. Or adjust the index to find out what the offset into the list of functions is going to be, basically. So that's what I need to do now. But this is a commit, right? So extract function at index helper. Well, I'll just say function at helper. And let's explain ourselves and saying we'll need this soon to interpret the function index correctly, because where am I going to find a citation for this? Where was it? In here, maybe? Because imports populate, well, let's say because function imports populate the identifier, well, the initial, populate a module's initial identifier context, and imports or populate the function's index space of a module's initial identifier context. I can definitely link to that. Where is it? Text format, modules. I want to link to this, but I don't know how. I'll have to link to just this whole section. That kind of sucks. And imports, and let's say imports go before, the indices of imports go before the first index of any definition contained in the module itself. We need to check whether a function index is pointing at an imported function versus a function defined in the module. Wow. At the moment, we don't have any way to import functions, so it's always a I don't understand how my fingers can type a different word than the one that my brain is saying, but apparently there's two independent parts of my brain that do these two jobs. So it's always a straightforward lookup in current module.functions, but soon we'll introduce function imports and need a single place to make this decision about where to look. Okay. All right, good. I think I'm going to add those to-dos while I'm in there. About why we are tolerating missing exports. I spent a bit of time remembering why these are here. It's because of it's because of tests which try to invoke, well, we try to reference exports from currently unsupported binary modules. Once we have binary module support, we should stop tolerating missing exports like this. Okay. All right. Okay. So where am I? All right. So I've got a place to make this decision, but there's currently no decision to make because we don't have any imports. So I think what I need to do now is, right now in the AST parser, I'm just ignoring imports. And so this needs to be, you know, imports, parse import, which is not something that is currently defined. So I'm going to need here def parse import. And we need to add imports here. And yes. Ooh, I will commit this to do shortly because that's something that is going to be needed even though it's not needed for this example. But I can ignore that. I can ignore that work for now. I just need to get this working, and parse text fields is going into the constructor of module. So module is going to need imports just like, right, function got import. This is going to get imports. And then in the interpreter, we're going to do this. That's going to be able to fetch the imports off of the AST node. And then what do we do with exports here? Do we just store it? Yeah, so this is going to need imports. And that means that this runtime module is going to need imports. So that's threading it all the way through. But at the moment, I'm not making any effort to populate it. So what was I previously doing here? Right, it was just repeatedly read. So has that broken anything? Yes. Undefined local variable imports. What did I forget? Oh yeah, that the imports needs to be initialized up here. I mean, this is by no means the first thing that I'm going to try to get working. I'm just trying to get the boring stuff done. Missing keyword imports. So is that not getting added to fields? I'm confused. Missing keyword imports. Oh, it's because binary fields isn't returning it. Okay. There's a little bit of boilerplate overhead involved here, but it's all okay. I'd rather have this. It's kind of annoying to have to be explicit all over the place, but it's actually a good reminder to be explicit rather than just have everything be a lot more vague. So I don't mind so much. Okay, so this is looking like I haven't actively broken anything yet. Obviously, I've changed lots of bits and pieces here. I mean, maybe it's okay for me to plumb this through. Yeah, I think it is. I think that is okay. I think I'll just do it. So hold on. How much do I want to bite off here? Let me just think, because it's a little bit hard to think when you're doing the interactive add. Not least because I don't know how to go backwards. I'm sure one of those 500 keys you can press will allow you to go backwards and change your mind, but I'm not sure how. So I definitely want this change in parse text fields, and then that involves also adding it to parse binary fields. And then that involves being able to accommodate it in the constructor of module. So I think that, let's just do AST. Let's just add these bits. So yes, 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 yes. Not that. Yes, that. Okay. Because I think that's fine, right? Like, for me to add unused stuff to the AST is not problematic. So let's say add parsed, well, add raw module import information to the AST, and I'll say this hasn't been properly parsed yet, but this is a place for it to live. So that plumbs it through at least. And I might as well add this as well. Yep, yep, yep. And let's say remember remember module imports from AST at runtime. These aren't yet meaningful, but they will be soon. Okay, so this is all just plumbing it through and making sure that those imports are available. And I'll just keep running this to make sure that I'm not making anything terribly broken. Oh. Wow. No, that stash is very old. Let's get rid of that. I did not mean to do that. That was I just typed it absent-mindedly. And normally I'm quite relaxed about typing things like that absent-mindedly because I don't normally have stuff on the stash that is not relevant. How bad is the stash? Ugh. I think I'm going to clear that, because that is just accumulated junk that I'm not using. Okay. Okay, well, I was just, the reason I popped the stash is because I was a little bit like, I was a little bit surprised to see only one to do, but I guess I've just committed all the other ones. Yeah. Okay, all right. So now what? Okay, so now I have to properly parse it, because at the moment I'm just ignoring it. So it's going to be pretty similar to this. Why not simply copy it? But let's think about what it needs to do. So the syntax here, again, let's do a Pepsi challenge with imports. So exports read the export keyword, they read a name, and then they read the export description. Imports read the import keyword, and then a module name, and then the thing being imported, and then the import description. So we need, at the very least, we need this to be like module name or something like that. Is that what we call it elsewhere? Yes. Import module name, import name. Yeah. So actually, how's that? How are we using that elsewhere? I know I just copied that from Parse Global. Right. So in the global, I've just made it a pair, a pair of names. And I guess that's what I did here. Yeah, okay. So if there's an import on the function, I'm just going to store this pair of names. But here, we need to be a bit more discerning. Crap, so we've got a parser type use here, which is going to modify the identifier context. And again, that's really problematic for the initial identifier context. But I'm just hoping I can get away without having to deal with that for now. You know, it means that when we're forming the initial identifier context, it's not just the potentially the IDs of imported functions that need to appear in the identifier context. It's also any type definitions that are generated when we parse this type use. You know, if no such index exists for the type that's being used here, then a new type definition is inserted at the end of the module. So I just have to hope that that's not going to be a problem. I mean, I can see it's not a problem for this test because, well, yeah, I don't know. Actually, I don't know. Maybe it is a problem. Like this, when I parse this import, I need to generate, this needs to generate an index. This type use has to point at something. So the type use is not referring to a type. It's not saying type 5. It's this abbreviation. It's this inline. You know, we're down into this territory that says, well, if you're just giving params, then we have to turn that into a lookup of the appropriate type. And if that doesn't exist, then we have to synthesize a new one. Now, I think that does all live inside. Yeah, maybe it's okay, because that's all just going to be done by parse type use. But my point is, it's going to do it too late in other situations. I think in this situation, it's fine. But in other situations, it might be important that the initial context contains that type definition. Is that true? Because we're not doing that for function definitions. That's called build initial context. Yeah, so maybe that's fine. Maybe as usual, I'm sort of overthinking it. So let's just go with the simplest thing that can work here. So we have to parse the module name and the name. So this export is going to have like module name and name. Now for exports, the kinds were func table memory global. Here they're func table memory global, so that's convenient. But yeah, it's a bit more complicated, isn't it? For func, yeah, that's the kind. But these have all got a second. Yeah, because actually the ID. So why doesn't the ID matter? Imports can bind a symbolic identifier. But how's that? How is that expressed? I guess it's expressed in the rule about the initial identifier context. Yeah. Right. Well, as I said, in this case, none of these introduce an identifier, so I'm just going to ignore it. So I'm just going to... well, it's not necessarily there. I'm just going to leave... I'm going to leave all of these cases out for now and just concentrate on the func case, because that's the one that I need to make this test pass, and then I'll get a pattern matching failure when I need to deal with these other ones. So what I'm doing here is, you can see that the synthesized attribute here doesn't include the ID. So what that's suggesting is, and this makes sense, right? We don't, for building the abstract syntax tree here, for building this should be import. We don't need to remember the name, the imported name of the function. Like, the name just goes into the identifier context, and then any references to that name get turned into the correct index. But we still need to skip over it here, so we have to be able to read it. So yeah, let's assume we've read that. Now we have to parse the type use. What does that return? So again, really don't care about the parameter names. And we're just going to put the type index in here. Okay. Okay. I think this is okay, except my previous definition here was just happily ignoring imports that it didn't understand, whereas now I'm worried that this is going to blow up because there were imports that we were blithely disregarding before that somehow weren't causing test failures, but that now are going to choke the parser because it's going to say, but you're not doing anything about this import of a memory or this import of a global. But let's see. Maybe I'll get lucky. Am I going to get lucky? No, unfortunately, I'm not. Right, so there's an import of a global in global.wast. Let's just look at that briefly, because maybe I can just implement that. So it'd be like 2 spaces, then import. Right, so there's... So it's actually only this one. Import spectest global i32. Global i32. I'm not sure what this... Well, I've just forgotten what a global type looks like, I think is what it comes down to. Okay, so we do need support for globals. What would that look like? It's going to be the same thing again. And then again here we're supposed to remember the global type. Is that important? Maybe not, but I think I'll do it. Yeah, I mean at the moment this doesn't return anything useful. I'm not sure I understand what this means. So it's like import... Oh, sorry, this isn't a global type at all. This is... Sorry, I'm just not thinking. This is this. So this is the import description. It's a global, and then its type is going to be this. Maybe I will just say... I mean, it doesn't do any harm for me to just stick that in here. It's probably not the right thing, but it is a thing. I mean, that's what I was doing down here, was just sticking whatever in. And I think I can do the same here. And at least this way, I'll be correctly supporting things like if it's mut i32, because the global type here, I can't just stick in read there, because the global type might not just be a single atom. It could be this list of mut with a value type in it. So that's probably the right thing to do. All right, so let me just see. Has that fixed that? No. Oh, well, why did I say parse index? That's not right at all. Oh, yes it is. So what's the problem? Oh, right. We should only call parse index when we know that we want to. Oh, right. So here those are all mandatory. Hold on. This isn't what parse index is for at all. I've got this, for better or worse. So I should be doing this. In fact, for all four of these, oh well, but the problem is you've got to read the thing first. So that's the right thing to do. This isn't parse index is for when we want to read when we want to read an index that is a reference to one that already exists in the identifier context. So essentially it's like a reference to an ID, whereas what we're reading here is not a reference, it's sort of a definition. We're saying I want to import some function and I want to give it a name. I want to locally call it $foo. And at the moment we don't have a helper for just reading the ID. We've just got this little snippet of like conditionally reading through this regular expression. And the reason why no one is ever storing this is because this should be implemented in it should be the build initial context that is actually reading this. If we look in build initial context, this is the thing that it does that, but then it actually remembers the name. Same again here. So we're going to need to repeat that down here. That's what this to do is. But for now, just have to do it like this. Okay, still not working. Uninitialized constant import. Well, that's fair enough. Import equals data.define. Okay. Now, because it seems like it managed to get to the end okay. Okay. So I'll just rerun these. Again, I haven't really got anywhere yet, but this is just proving out that the boilerplate is not actively broken. Okay, it's looking okay so far. I don't think I've got to the problematic point yet, though. Okay. Okay, cool. So okay. I don't think I need those to-dos in there actually, because it's just that's already encapsulated by the to-do I already have. Like that's redundant. I'm already doing this all over the place. Like I'm reading IDs and throwing them away because I'm not in the right place to use them. So this is just the same pattern as I'm using elsewhere. So I think I've got something I can commit here, and it hasn't broken the tests. So let's say like introduce import AST node. and build it in Parse import. Let's just say the tests only require us to parse, what is it? Import func and import global. For now, so I'm only implementing those. I've got the syntax right there. Import, and then in brackets, func. Yeah. Okay. So now I suppose it's time. I've got the opportunity to do something in the interpreter. Because now I've got those imports available. So when I say find function at, why can't I type? So here I can say puts finding function at index, and let's just right, I'm still working on names. In fact, I can remove I don't need the local copy anymore. We're going for it. So this is finding function at index 2. Now I just want to check and say current module dot functions we're going to see what those are, and then I'm also going to look at imports just to see what those are because this is where I'm going to put my logic about finding the right thing. So you can see we've got an import. Module name is spectest. Name is print i32. Kind equals func. Index equals 0. So this should be index 0. This should be index 1. This should be index 2. So I think what I was going to do is going to work here. So let's just think about how this is going to work. Firstly, I need to do something a little bit like this, but instead what I'm doing is, well, what I need to do is first sort of filter the imports because I need to index into them. When I was looking for one with a particular name, I can just search through all of them and just ignore the ones that aren't of the right kind. But now that I'm indexing into them, what I need to do is sort of say imported functions is current module dot imports dot select import. This is getting a bit. So this is going to be import in kind func, right? Is that the right method name? I'm never 100% confident that I've remembered the right one. Yeah, that's right. Okay. So select all of the, well, maybe this should be function imports because they're not actually functions. They are imports, but they are imports of functions. Okay, so that'll find me all of the, right. And now I need a conditional that says if index is, let's not get it off by 1. Less than function imports dot length, then then like use imported function. Else, so we now want to do this. Well, let's keep this for now. You know, this is going to be like puts trying to use imported function. So I just want to see that happen at the right place. Oh, well, actually, this was trying to find the function at index 2, right? So puts trying to use defined function. And so what we need to do here is just adjust this index minus function imports.length, because these, we need to think of these as coming after. Well, I mean, I guess I could just cook up an array that contains both and just index into that. But the thing is, I don't know what I'm going to do here. I can't just return the import. I mean, I suppose I sort of could. I've got to return something. Yeah, I mean, that's actually a little bit tempting. Well, for now, I'll keep them separate. Okay. So look, finding function at index 2, trying to use defined function, like that all worked okay, and there was no problem. But we're still in the same test where it's now trying to call function 0 at this point. So that's what's happening here. Finding function at index 0, it's correctly identified. It should be trying to use an imported function, and then I assume this is invoke function is choking on it. Yeah, invoke function is choking on. I guess it got nil. Yeah, because we're just returning nil in this case. I think what I am going to do is just return the import for now, because I don't have anything better to return. So I might as well do function imports dot slice index. And like I was saying, this whole thing could have been achieved in one go by just concatenating function imports and current module dot functions and then slicing into that. But I don't think I want to bake in that behavior. Because this is still going to fail in just the same place, but instead of complaining about nil, it's going to be complaining that it's got a undefined method type index for an import. So what is this? I feel like I'm going mad. What's the index here of the import? Right. So yeah, I mean, this isn't really right, is it? That thing called index. Here, we always had, for exports, we always just have an index. For here, we have different stuff. X here might be... So X actually is an index, but it's a type index. Here, what's TT? Table type. I'm not quite sure what this means, because table type synthesized attribute is a sort of a pair of things, but maybe that's the intention. It's just a bit weird because here type use returns. Oh, I don't know. I don't know how to. I don't know what this means syntactically. Lim et. That's a record. Oh God, I don't know. I don't know. It's something unclear what you get back from parsing a table type, but you get something. Mem type. Oh, you get this limits record, so it's not an index. And here, global type. Right, you get. So I think maybe if this was going to be called anything, I think it'd be better if it was called type, because that's actually, it's not really an index. It's some kind of type. And I think that would be less misleading. So let's call this type. That's closer to being correct. I mean, really, this whole situation is a bit of a mess because, you know, we actually want a sort of an algebraic data type here to allow you to put a different payload in depending on the kind. Like, there's no constraint that says that these all have to be the same. And I mean, I guess that's what we're... Yeah, we're just saying that table type... Yeah, okay. These do all happen to be a sort of a typey kind of thing, but the fact that table type is actually this... I don't know if this is supposed to be a pair, or... I just don't know what it means when you write two things next to each other like this. But yeah, anyway, let's call it type. So that means that my previous commit was actually not quite right. But at least now this is going to complain that this thing doesn't have a type index, it only has type. So that's okay. So let me just... Yeah, it is just the previous commit, isn't it? So it's AST, and I think, well, and that. Yeah, so I think that's more what I meant. Okay, so now we're getting the right. Now we're getting the right thing. So for now, I think I'm just going to patch up invoke function so that it can deal with receiving an import. So here, let's say case function in function. We do all that cool stuff. And then here we have to say in import raise, oh no, it's an import. And then hopefully that's what will happen. Yeah, oh no, it's an import. Okay, so what do we actually want to do in that case? Because we need to do something because it's consuming this argument. So we've got to do some of this discipline, but like, I don't actually have this implementation. Well, let's say Yeah, maybe this is the thing to do. Like, what is it that you've imported? Because this is what I did in the other place. You know, in a totally different way. But this is just about, oh yeah, I mean, this is a real dog's dinner. Well, this is dealing with inline imports, I guess. All right, don't fixate on how much of a dog's dinner this is. So what I could do here is say like, spectest. So now there are two places. Name is print I32. I assume that's also going to be in quotes. Well, let's say in import type, no, sorry, kind, func. Yeah, and let's look for the, just so that it's obvious why I'm doing this and under what circumstances it's okay to do the following. It's like assuming that what was imported here was one of the modules, was one of the functions in spectest, then let's just say we're going to pop, well, we've got to find the type. So as far as possible, I'm going to try and use the information I've got here. So current module.types slice, and now this is function.type, because type is just an index in this func kind. Pop off the argument values. And then I don't think I have to do anything else. That's it. That's the end of that. That's the end of that. I'm not going to evaluate anything. I'm just removing the right number of values from the stack. Well, and why don't I just be specific about what I'm expecting here? Name, print I32. Because I can always add more in here. I can always make this an alternation pattern and say if it's print I32 or if it's print I64 or whatever. So let's see what that does. Okay. Where's that? So is this, the question is, has this got any further? No, it hasn't. Undefined method map for nil. So what's this trying to do? Let's just see what's happening. Puts invoking function.inspect with stack.inspect. So what situation are we in? Okay. That's too much noise for me. Let's just do this bit. Okay. So invoking function. So we're expecting it to invoke print32, which is actually defined inside this function. So that's, and this is print32, local get 0, call, okay, with stack 42 and 123, correct. Invoking function import from spectest with stack 42. Invoking this function, oh, which has no locals or body. Right, okay, yes. All right, so, right. So this this import has worked fine. This one has not worked fine. So this should be like import, if import is nil. So this is a function that doesn't do any importing, and now we should get a pattern match failure here. Yeah, no matching pattern error. Okay, because essentially, well, I guess we can just, it'll just fall through here. Essentially, we want to do the same thing. You know, this is going to be, look up the correct type. So what was it trying to import? Spectest print I32, yeah. So it's a similar thing here, right? Well, I just realized that it's actually easier to check whether something's nil in a pattern match than having the guard on it. So, right, it'll still have the correct type index. Yeah, I think that's right. Yes. So I can take out my debugging putsing. Okay, and now hopefully, right. Okay, so again, lots of hacking that I don't feel good about. But what that's done is plumbed in. Now we support like imported functions of both flavors, and you can see that there's some duplication here where, because this is the inline import and this is the explicit import, but I haven't combined them because actually the way that we look up the type is different in those two cases. Error pending test passed, right? So what's the right order for me to do this in? I think, well, it's probably just the order that I did it in. So what's this? This is, I think that stands alone basically, and this is like support imported functions in function app. So let's say at the moment I've decided to just return an import instance instead of a function instance, which isn't very good. But the only thing that needs to deal with this is invoke function. So for now, I can just make sure it knows what to do with an import. I'll do that in the next commit. More generally, we need a common representation of invocable function, regardless of whether it's defined in WebAssembly or in native code as per spectest. I don't have this representation yet, but it could probably just be a proc, question mark. I'll think about that later. Okay. And then, okay. So I want to add this in two pieces. So I'm gonna not put this part in. I'm just gonna put the explicit import, the sort of top level import. So let's just run that test and make sure that this is sensible. Yes, that's what I was expecting. So it's complaining about the fact that the function it's trying to invoke doesn't have a body, or it doesn't have locals actually. But either way, that's the problem. So let's say support top level imported functions, or imported spectest functions in invoke function. If the module has a top level import spectest print 32 func param i32, am I missing a, yeah, I was like, what's going on with the parentheses? If the module has a top level import spectest there, then we can invoke that by just popping its one argument off the stack. In principle, we could print that value out, which is what print 32 is supposed to do. but I don't actually want to see that output. I don't actually want to see that in the test output. So we'll do nothing instead. So this does at least verify that all of the hygiene around the type indexes is working properly. So that's better than nothing. Okay, so now what we got? Okay. So no, I just want all of that. Again, this is this is such a dog's dinner at the moment, but I'm just going to keep reassuring myself that this is a temporary workaround. I'm not expecting this to live on functions indefinitely. So let's just say support abbreviated, or let's say support inline imported spectest functions in invoke function. And let's just say this is the same behavior as in the previous commit, but for syntax that looks like func import spectest print i32 param i32. Ultimately, we'll need to unify these two approaches by having this syntax generate an explicit import rather than simply storing that information on the AST node, on the sort of otherwise unused AST node for a function definition. But that's a future problem to solve once everything is working. Okay. Oh, and also I think in that commit, I'm going to need to move names to here because now it is working. And I assume func pointers is still not working, so let's just run the test to double check that. Oh, this is what I did last time. I forgot to amend that commit. Okay, and then this is just add imported identifier to build initial context. This is slightly odd because we need to update different index spaces depending upon the content of the import. But it's important that we do it so that imported identifiers are visible to the rest of the module. Oh, wow. Func pointers is passing as well. Wow. Okay. Rock and roll. I did not realize that. Okay. So this is actually making two tests pass. And I assume, let me just verify this. I assume that here not only was names wast failing, but also func pointers was failing. Yes. Okay. Okay. Well, that's pretty good. Well, it's not that good, is it? I've made more mess, but in exchange, I mean, I think the positive spin to put on this is that I've got the bones of importing working now. I mean, I'll take BR table for free, but I've also got names and func pointers here. Where's my list of tests? So I'm now down to 4 remaining things here, some of which might be more difficult to deal with than others. But I think that's decent progress. And actually, I am quite sleepy, so I think rather than forcing myself to stay up for another 3 hours just to be, you know, extremely hardcore or whatever, I think I'm just going to wrap it there, because I feel like that's a good stopping point, and why force myself to to keep going. So let's push that up. Let's see the tests pass. And then I can wrap it and not be absolutely exhausted tomorrow. So that's like a whole new idea of being, I'm not sure what the word is, responsible? I don't know what that is. Okay, so let's see, is this going to pass? I mean, by the way, I never really mentioned this, but part of the reason why I do this, well, 2 reasons. Number one, even though I always run the test locally, but number one, is GitHub Actions still using a version of Ruby that these tests pass on? You know, especially during the release process of Ruby 3.2, I wanted to make sure that whatever version of Ruby 3.2, the sort of setup Ruby GitHub action was using, that the test would pass on it. So this is verifying that. But also slightly more subtly, the other thing it's verifying is this checks out the latest version of the WebAssembly spec every time. So even though locally I'm not updating it, which perhaps I should, but like the reason I'm not bothering to update it locally is because I know that the GitHub action is going to be running against the latest version. I mean, if we look at when it did the checkout here, oh, I thought this was going to be quick, but it's not. But here, when I checked out the WebAssembly spec, I think it's checking out the latest version, right? Yeah, checking out main. So this is running the test against the newest version of the WebAssembly spec. So if there's ever an upstream change in the WebAssembly spec that causes my test to fail, this is my canary in that specific coal mine, is that this, if I don't get the green tick here, then that tells me that I need to do the thing I've never done, which is go and update my local copy of the WebAssembly tests and then run the test suite locally, and then I've got something to debug. But this is the kind of belt and braces. Let's check that not only does it work on my machine, but it also works on GitHub's, on the version of Ruby that the setup Ruby action is using, and on the current version of the WebAssembly tests. Oh look, we're getting dangerously close to 1,000 commits. That'll be another fun milestone for me to mark for no important reason. Okay, well, like I said, I think I'm going to wrap it there. That was enough for one night. I'm satisfied that I got a couple more tests passing. I am a little bit worried about the mess that I'm creating with the way I've implemented these imports, but I'm sort of comfortable. I know myself well enough, and I'm comfortable enough with software as a material, I suppose, to know that I can shake all of this out later. That like, if I can just get everything hooked up so that I've got the test passing, then it's relatively easy for me to go in and move all of this furniture around and tidy it up and make it less revolting. So I'm not too worried about accumulating like tech debt here, because I mean, however legitimate a concept you think that is, in this case, the real difficulty is plumbing all the pieces together. And then once I've got everything plumbed together, it's not that hard for me to change my mind about how do I want this particular thing to work. I just have to move it, change how a bit of the parser works, and then massage that change through into the interpreter. And like, I don't feel too worried that I'm massively painting myself into a corner here. I am definitely, I want to say cutting corners. Is a different kind of corner than the one that I might be painting myself into. But like, I feel like it's vaguely defensible for me to take these shortcuts at this point and just jam that stuff into the data structure wherever is most convenient right now, because it's pretty easy to do that kind of refactoring. Like for me to just move things around, make some of those parsing functions emit more different kinds of node, or have a more sophisticated internal API in that parser that makes it possible for nodes to be inserted in different places in the AST as the source code is being parsed or whatever. Like, I think I can deal with it. I just don't want to deal with it right now, because I'm enjoying the momentum of getting more stuff plumbed in, getting, understanding more of the language spec, wiring up more of my implementation to implement those things that I've just understood, and just like trying to keep barreling forward and get more of these tests passing. And then in a couple more sessions, I can have another of those sort of therapeutic refactoring sessions where I go back and wail about how messy it is and move things around. And it's very time consuming, but it's very satisfying to shake it around and have everything settle into like a lower energy state. So I'll save that up for a future session. But for right now, I will... my button never works. My buy button doesn't work. Anyway, bye. I'm going to go to bed now. So this was a short one. Short show. But it's still quite long. So thanks for watching it. Still longer than... I don't know. I want to say longer than Schindler's List. Is that... I don't know if that's a unit of things being long. Probably longer than Return of the King. So that still counts as pretty long. But yeah, I'll say what I always say, which is I'm really grateful that you're watching this and giving it your attention. Again, I feel like I should apologize for a not especially interesting session, but this is just the grind. I'm in it. I'm trying to grind through these tests. I'm making compromises. I'm getting confused about the language spec. I'm just doing whatever it takes to make progress on this project. So yeah, I'm going to keep doing that for the foreseeable. I hope you'll keep joining me. So yeah, thanks very much for your attention and your implicit support. The fact that you're bothering to watch this means a lot to me, so thank you. All right, I'll see you next time. Bye-bye.